Hi and welcome to this video in the MRDCL Fundamentals series. In this video we're going to be looking at mean score summary tables and how you can approach them in different ways and why different approaches work better in certain situations, and also to explain the tools you've got. You'll find the files for this video in the folder tab 04. So the sort of table I'm looking at here is something like the one you can see on the screen now, and that's where we have a series of mean scores, possibly for a series of rating scales, brands, rating statements, whatever they might be, where we want to just see the mean scores one underneath the other. We're going to move on from that and look at how we can get those ranked into order as well, and we'll use two techniques to do that. So let's first of all look at the script we've got and how we might approach this to get the basic tables first of all, and the rules you have to follow. So here's the script that is producing those tables. I'm going to scroll down a little way and you can see there's a data statement 50 which picks up the text for the 8 rating scales called rating 1 to rating 8, and a statement that counts how many there are, so it'll return in ratings a value of 8. And now I'm performing a loop of 1 to 8, picking up the data 1 to 5 for each of the rating statements, which are in data locations 113, 114 up to 120, putting that into another variable where I'm getting a top 2 box here, so you can see I'm picking up codes 1 to 2 before I pick up the 5 codes on the questionnaire, and coming down here with V labels and H labels. But I want to draw your attention to this extra variable that I specified here, and this actually is a really nice construction that's very fast to use in MRDCL. What it's saying here is, in my loop, I'm saying I'm defining a variable that's an integer called Q2A up to Q2H, which I'm taking from the variable XQ2. Remember, XQ2 just picked up the 5 codes. I'm assigning a value of 2 to the first code, 1 to the second, 0 to the third, -1 to the fourth, -2 to the fifth, and I'm setting the 6th one, which is the error bit on our variable, to undefined. So if we go back up, you'll see it's actually picking up the values in these variables and assigning 2, 1, 0, -1, -2, and undefined to the 6 possible responses that you have. So that's my data stage. I'm now going to produce the mean score summary table. And you can see the main thing I'm doing to achieve that is a loop. So it's going to loop through the 8 rating statements. And to get the relevant text I want, I'm putting in percentage AVG and replacing it, the standard AVG, which would just say mean score, with 50.A. So data 50 is the data statements holding the text rating 1, rating 2, rating 3 up to rating 8, which we found up here at the beginning of the video. So now we can pull in a piece of text that's going to replace the word mean score. If I don't put that, every table will be called mean score. So let's just do that. Let's take that out, run again, and we get a table that's not very meaningful to us, that just says mean score, mean score, mean score, because they're the default text coming out for every single table. All right, so let's put that back in. And now it's going to go around my loop. And what I'm telling it here, and this is quite a common thing to do, I'm saying skip to the statement 11 on the first time round the loop. So when A is equal to 1, I want to skip that plus. The plus means I want to put it underneath the previous table, because what I want to do here is show Q2A, Q2B, Q2C, Q2D through to Q2H underneath each other. What's more, I don't want to see the distribution, I just want to see the mean score. So this is going to put a plus on everything except the first table. If we look in the listing file, this might be a little bit clearer. Let's go to table 1. Here we are. We can now see that it's still leaving that comment there because I've just run it just now. T1A is Q2A by age. Q2B is the table statement for table 1B, and so on down to H, and you can see I will be changing the AVG each time once I've taken those comments off. So back to our script here. So those comments have gone now. We've got AVG here. That's going to put the plus on everything except the first table. This is going to give me a unique table number, table 1A through to table 1H. NDIS and NAID. NDIS means I don't want the distribution. I don't want to see all the rows coming out saying very good to very poor. I just want to see the mean score, so that's all I get. If I don't put that N there and run it again, what I'm going to get is quite a lengthy set of tables now, so I'm going to see all the strongly agrees with my mean score here, but I want to suppress all of this information here. So what I want to do is I want to get rid of all the stuff highlighted in blue and just show the rating 1. That's all I want from my table. So let's go back to table 1. Here we are again. We've got NDIS NAID. Now NAID means suppress any alpha in the table number, no alpha in the table ID. And what that'll mean is rather than having table 1A come out and using that in the table number, I just will get table 1 out, which will look a little bit neater. I'm putting out here Q2A to Q2H, and I'm analysing it by age. Now this is important too. Now I want to set a title, but I only want to set it for the first table because that's all it will look at. Because all the others are plus T underneath it, I don't want to see any titling or replacing any titling that may have been specified against individual variables. So I'm skipping round if it's not the first time in the loop this time and putting the title in mean score summary so that it comes out. If we look at the listing file again, that will make a bit more sense. You can see here I've got the word mean score summary coming out, but then it's skipping it for all of the other times that we have that particular table. Alright, so now we close the loop, and it's a good practice at the end of any time where you're resetting an AVG to set it back to the default again. If you don't, it's very easy to leave the last of these AVGs, which will be rating 8 in this case, appearing on any tables where there's a mean score, and that will look, again, rather strange or silly in your table output. So a good idea, once you've used a loop with an AVG being set, to just reset it back to mean score, even if you are going to set it again further down here. Alright, so let's done table 1. So let's just set that back to NDIS, and let's just run that once more and have a look at it. And you can see what effectively I'm getting now is I'm getting table 1A here, I'm getting table 1B here, and down to table 1H at the bottom, and the mean score label, which would be mean score without replacing it, is coming out as rating 1 as in the data statement 50. So that's doing my summary mean score. Now that's all very well, but what if I wanted to rank them so that rating 8 went to the top of the table and rating 3 went to the bottom, being the lowest? Now there's two other techniques I've got for that, and I'm going to show you both of those. I'm going to look at the table 3 that I've got here first. And there's a format option called RNS2. Now what RNS2 is a special option. When it's set to a value of 0, it means the stats aren't ranked. When it's set to 1, it'll take the first row in the table, so we could rank it on the number agreeing or something like that. But when it's set to a value of 2, it's taking the mean score. So it's going to do the same thing as before, but it's going to now rank my mean scores, and I'm doing it as table 3. Now there is one or two minor differences here that you need to take into account. First of all, the total row, all the tables that you're ranking must be plus T tables. So we need to have a separate total row, and I've done that by saying that table 3 is star $age, which means it gives me a total only row by the banner age. And then it knows that RNS2 means that I want to rank all of the rows that follow that are plus T tables. So it will rank my Q2A, Q2B and so on, and it will use my NDIS so that it hides the distributions for me. So it's just the same as the first table we looked at. Again, it's good practice to set it back to RNS0 afterwards, as it might rank things that you don't want it to rank. but effectively we've almost done the same table as table 1 with this difference here, but otherwise pretty much the same process. And sure enough, when we run that and we look at table 3 here at the bottom, rating 8 comes out top, rating 2, 4 and 5 follow, and rating 3 comes out the bottom because it's the lowest rating scale, which matches what we've got here with rating 3 coming out as 0.7. Of course, it is logical place here because it's not been ranked. So that's one way of ranking mean score tables. There is another technique, and I'm showing you this technique because it does actually help when you've got very complex tables, and this is doing mean scores by table manipulation. Now, in this particular case, I think RNS2 is probably an easier way to do it, but there are times when you do very complex tables when actually incrementing cells of a table or rows or columns of a table is an easier way of doing it. So let's look at that now and have a look at what table 2 is doing and how that's working to produce what we want. So you may remember this variable here where I held an integer that holds the score that's been assigned to each of the responses. 2 for the agree strongly, 1 for agree slightly, down to -2 for disagree strongly, and undefined for anybody who didn't give an answer. So that's the IQ2 series. Now here, what I'm going to make 2 tables. I'm going to make a table 2, which is going to store the sums of the scores for each of the rating statements. And then I'm going to have a table 2x, which has the basis for the number of people that answer that, and then I'm going to divide one by the other. So let's see that in a little bit of a step-by-step process. I'm first of all going to comment out this table here and this table here, and effectively nothing will be incremented. So what we're going to get is 2 empty tables. Let's run that, and what I'm getting out now, if we look at table 2, is an empty table. I'm going to do one more thing now to table 2x. Table 2x is holding the number of people in each table, so I'm going to also take the n off that so it prints it. And what I'm going to do now is show you these tables without the manip code that's going to divide one by the other. So I'm commenting out the manip, and let's see what I get. So table 2 now is effectively the sum of the scores for each of the ratings, and table 2x is the number of people that answer those ratings. So what this is saying is that here the total score for rating 8 was 6 points, and that was given by 3 respondents. And when I divide one by the other, I'll get my score out of 2, which is the highest ranking score. So let's look at that in a little bit more detail in the code. Let's go down to this table. Here we are. I'm now going to put n on the front of this, so it's NPTB, so it doesn't print this table. I only want it for calculation purposes. But let's look at what's going on inside this loop. So we're looping around 8 times. For the table that's 2, not 2x, I want to scale it by the value in IQ2A, IQ2B, and IQ2C up to IQ2H in the rows 1, 2, 3, 4, 5, 6, 7, 8. So what that's going to do, it's going to scale row 1 of table 2 by the value in IQ2A through to the value in IQ2H for row 8. So that's going to give me the sum of the scores. Now this line of code in table 2x is going to find out how many people are undefined for each of the rows. So now it's saying if IQ2A is not undefined, I want the number to go in row 1, row 2, row 3, up to row 8 for IQ2H. So effectively table 2 is holding the sum of the scores. Table 2x is holding the number of people giving those scores. Now what that means is in manip, if I take that comment off, I can just divide one by the other and say that table 2 is table 2, which is the sum of the scores, divided by the number of people that gave each of those scores. So we could divide in one table by the other. Now, how's it ranking that? Well, it's ranking that because the variable I use for my rows in the dummy definition of table 2 is Q2 done. And if we look at Q2 done, there it is. It's specified as 8 empty rows, and it uses the the label control G1B to rank those rows so that it begins ranking. G1B means begin ranking, and it's only beginning ranking at the first row. If we look at the listing file, we can see that a little bit more clearly. So here's our variable Q2 done, and we get G1B coming out against rating 1. There is no closure of that ranking, so it's going to rank all rows. If we had G1E on one of the lines, it would end at that point. But we're ranking all the rows, so what it's going to do, it's going to rank the mean scores in descending order because it's got that G1B. So when we run it now, sure enough, table 2, if we go down there, looks exactly the same as table 3. Now, I think you'll be right in saying that in this example, table 3 is probably an easier way of getting the ranked mean scores, but where you've got complex calculations going on, sometimes you'll find that doing it the way that table 2 has it will be an easier approach. So that completes this video on producing mean score summaries and ranking them if they're needed. I hope that was helpful to you. Thank you.